A very good morning to the students of class 9, and as we are discussing, we have completed the syllabus for chemistry and we are discussing regarding the revising, revising regarding the chapter structure of atoms. I hope you, this is only for you that you need to have a better concept, as I told you in my previous class also, that this structure of atom is a very important chapter for chemistry, and as you go to the higher classes, provided you are interested in joining the science stream, this chapter will be a very important one. So I expect that you go through the video properly, because this is again a revision part which will make your understanding and your concept more clear, and you will have you will know actually what is, because atom, as I told you, it is the fundamental matter, a fundamental unit of every matter. That is why it is very important to have a complete concept. And you just imagine that atoms is such a minute one, it is so minute, but still then this the structure of atom is so important that it is actually you need to know it. And there were various scientists who actually made a study about the structure of the atom. And what was the structure, means who was the first one who made the study on the structure of atom was J.J. Thomson. So he made a definite study about the structure of the atom, and he found that there are subatomic particles like protons, and which is a positive charge, and also the positive charge is being confined in the center of an atom. So as we move on, that is then after that it was Rutherford who actually gave the idea that it is made up of a it is made like a sphere, and then the electrons are embedded inside it, just like the watermelon, where the red part is the atom, and the electrons are being can be compared to the black color sheets which is embedded inside the watermelon. So as we actually and this that is the red part of the watermelon is embedded inside the positive charge. So that means it is a positive charge, and the electrons, they are electrically neutral. So what is the proposal which Thomson gave, that the atom consists of a positively charged sphere, as it is compared with the Christmas pudding or with the watermelon. So it is a sphere where the sphere is actually positively charged, and then the electrons are being embedded inside it, and then when the negative and the positive charge, they are equal in magnitude. That means the number of positive charge will be equal to the number of the negative charge, and so the atom as a whole is neutral. So that means they are electrically neutral, because the number of positive charge is equal to the number of negative charge. So this Thomson's model did fail, but it tried to explain that the atoms are electrically neutral, and that is actually so. And then the results of the experiments which were being carried out by the later scientists, that could not be explained by this model. So there were other further investigations and experimental investigation to find out more about the structure of an atom. Now after that, it was Rutherford who made an attempt to know about the structure of the atom. So he selected a tin foil of gold, and why he selected the tin foil of gold, because gold is a highly malleable metal, and it can be turned into thin sheets. That is why he wanted, for his experiment, he wanted a very thin sheet which could for which he could bombard the alpha particles in the gold foil. So when he selected the gold foil because he wanted, as I told you, he wanted a thin layer as far as possible, and then this gold foil was about 1000 atoms thick. So you just imagine one atom is very small, and then when you are combining a 1000 atom thick, that means it is a very thin foil. And then he also selected the alpha particles because alpha particles are doubly charged helium ions and they have a mass of 4 units. So when you are talking about the helium ions, that means it is a heavy particle, and when it will be bombarding the gold foil, then it will bombard with a great force. And then he expected that the alpha particle would be deflected by the subatomic particles. Now, as I told you, what are subatomic particles? That is the protons, neutrons and electrons, right? And then in these gold atoms, since the alpha particles were much heavier than the protons, that is why he did not expect such deflection. However, the alpha particle experiment which was being carried out by Rutherford was beyond his expectation, because he did not expect this type of result. What type of result is that the alpha particles, most of the alpha particles, they actually pass through the thin foil without any deflection, and some of them, very few of them, deflected away. Like suppose most of the alpha particles actually when it was being bombarded along a gold foil, then what happens, these alpha particles were most of the alpha particles went straight without any deflection. Very few of the alpha particles were deflected by a small angle, and 1 out of 12,000 particles rebounded. That means it came back. So that means this alpha particles, what happened, it went, and after that, after striking it, 1 out of 12,000 came back, and Rutherford was so surprised that he told that this was actually he told that the result was about like you are as if you are firing a 15-inch shell, that means a bullet, on a tissue paper, and it comes back to you. Just imagine, a tissue paper is such a thin paper, and in fact it is thinner than a paper itself, and then when you are holding a tissue paper, and then you are firing it with a 15-inch bullet, then or a shell, then what happens, you find that it strikes and then comes back. So just imagine, that means the level of coming back, striking a tissue paper and then coming back to you. So right, so that is why it actually did not meet the expectation of Rutherford, because he expected that there will be larger deflection. So he did not expect that it will rebound back. So if you think about this Rutherford, so what was the reasoning that Rutherford concluded? What was the conclusion that Rutherford had from the alpha particle scattering experiment? That most of the space inside the atom is empty. That means the atom as a whole is not empty, but most of the space is empty, because most of the alpha particles pass through the gold foil without getting deflected. So as the alpha particles were moving on and striking the gold foil, and then what happens, this striking the gold foil and then it is passing through the gold foil, then it means that the alpha particle, that the most of the part of the atom is what? Is empty. So the second conclusion that he had is that very few particles were being deflected away from the path. That means what happens, the surge of the atoms occupies a very little space, right? And that means when the alpha particles were deflected by the small angle, that means the positive charge of the atom occupies very little space. So the third conclusion is that a very small fraction were deflected by the straight angle, that is 180 degree. That indicates that all the positive charge and the mass of the gold atom were concentrated within a small volume. That is, the positive charge and also the positive charge and the mass of the gold atom is, that means what is the mass of the gold atom? Naturally, it is the nucleus and the protons. So that means the mass of the gold atom is concentrated within the center of the atom. And then so on this basis of his experiment, so Rutherford put forward the nuclear model of an atom, which had the following. What are the features? That is, the positively charged center of the atom is known as the nucleus, and nearly the mass of the atom stays inside the nucleus of the atom. And then the electrons, they revolve around the nucleus, in circular orbits, and the size of the nucleus is very small as compared to the size of the nucleus. So that was the features of Rutherford. And please go through the video and try to have a better concept. I hope you all have understood. If not, then please do come up with your doubts in the Zoom class. That's all for today, and thank you very much.